Right, so this is another video because a lot of people really like the video format. So here's a video in terms of how do you draw Lewis diagram. Now here's a couple of the steps already. First step, find the total valent electron for the molecule. Put the least electronegative atom in the middle. Hydrogen always go outside. Put the 2 electron between atoms to form a bond, complete the octet on the outside atom, and if the central atom doesn't have an octet, move electrons from outer atoms to form double or triple bonds. Okay, so you do need to kind of use and remember your periodic table a little bit to do that. So first off, CH4. So if you remember your periodic table, this will be 4 valence electron, 5, 6, 7, and 8 valence electron. So carbon itself will have 4 valence electrons, and hydrogen, it only have 1 valence electron. So in this case, 1 valence electron. But keep in mind there are 4 hydrogens, so it will be times 4, which is 1 times 4 is 4. So total, you'll have 8 valence electrons. Okay, so let's found that out. Step 2, put the least electronegative atom in the center. When we're talking about electronegative, we're talking about non-metal and non-metal. So basically, the closest to this line, if it is a non-metal, the closest to this line, the least electronegative it will be. So carbon is basically touching the line. So carbon will be in the middle, and hydrogen, we're going to put hydrogens around it. Okay? Hydrogens are always outside. Put 2 electrons between the atoms to form a chemical bond. Now, what I do want to deviate a little bit is this. Carbon has 4 valence electrons. So carbon will have these 4 valence electrons. Hydrogen have 1 valence electron each. So I'm going to put 1 here between this hydrogen and this carbon. This hydrogen, this carbon, this hydrogen, this carbon, this hydrogen, and this carbon. So basically 2 electrons between the atoms to form bonds, complete the octet on the outside atom. So if we look at the hydrogen, to have a full shell, it only needs 2. So this hydrogen, it's happy, has a full shell. Same thing for this hydrogen also. Same thing for this here. And same thing for this hydrogen here. So all the hydrogens are happy because they all have full shell. Carbon, the central atom, carbon, in this case, it also has 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Do keep in mind when we're talking about covalent bonds, non-metal, non-metals, the electrons are shared. That's why these 2, it looks like it belongs to this hydrogen and also this carbon. Okay, so this, you can draw the Lewis dot diagram like this, or you can replace each pair of electron, replace the 2 dot by a line. So in this case, you have this here. Okay, so you can always do this way or this way. Depends what I ask for. Okay, so hopefully this helps. Example number 2, NH3. So first step, total number of valence electrons. Nitrogen have 5. So in this case, nitrogen, 5 valence electron. Hydrogen, again, 1 valence electron, but there's 3 of them. So times 3. So in this case, you have 3 valence electron from the hydrogen. So you have a total of 8. Again. So here, nitrogen, I'll put nitrogen in the middle. I'll put hydrogen. Now, I would put 2 electrons. Now here, Hydrogen will have 5 valence electrons. So we'll have 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. I kind of put only 1 here between the nitrogen and hydrogen because I know each hydrogen has 1 valence electron. So the crosses will be the valence electron from the hydrogen. Okay, so I did that. Let's check if the hydrogen have full octet. This hydrogen have 2 electrons, so this one is good. This hydrogen has 2 electrons, so that's good. This one also have 2 electrons, so that's good. Now this my central atom, nitrogen. It has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. So nitrogen is also happy, has a full octet. So the good to write this more neatly, nitrogen would have this. You can draw like this with the dots, or now you do, when you replace these 2 dots, it's a line, okay? But the line has to be in between 2 atoms. So this is the reason why, because you still have the 2 dots here because there's no other atom between this nitrogen and this. This is just empty space. So you'll leave the 2 dot as is. But if it is dots, the pairs of dots in between atoms, you can replace it with a line, okay? So either this or this, either one's correct. Example number 3, we're gonna look at CO2. Now carbon, we were doing carbon earlier, it was 4 valence electrons, so that's good. Oxygen, if you look at the periodic table, oxygen will have 6 valence electrons. So in this case, 6, and there's 2 of them. So which means you have 12 oxygen electrons from oxygen, which gives you a total of 16 valence electrons. Okay. Now this one, put the least electronegative atom on the center. Now this is the first time you don't have hydrogen. So which one should be the center one? Well, let's look at again. Carbon is, remember, whatever is closest to this line is the least electronegative. So carbon is touching the line, oxygen is over here. So carbon would be in the center instead. Okay, and put the 2 oxygen on each side. Now carbon has 4 valence electron. I'm just going to put 2 here and 2 here. Oxygen, each oxygen have 6, right? So we'll have 1, 2, 3, 4. I'll do crosses. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now this part here complete the octet on the outside atom. So let's check if the oxygen have full octet. This oxygen here has 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen is good. I'm just going to put a quick check mark. This oxygen here has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. So this is good. Now the central atom. This carbon here, if you look, it only has 1, 2, 3, 4. It does not have an octet. It wants 8, remember? So in this case, if central atom does not have an octet, move electrons from outer atoms to form double or triple bonds. So what it means is that since this one is short of 4 electrons, what I'm going to do is I'm going to take these 2, I'm going to move it in between them, and I'll do the same thing for this one here. I'll take these 2 and put it in between this carbon, and this oxygen. So I'm going to rewrite this. So between this carbon and this oxygen, you have two pairs of electrons between this carbon and oxygen. And this oxygen will still have 1, 2, 3, 4. Here, between this other oxygen, also two pairs of electrons. 1, 2, 3, 4. The reason why I kind of moved it is because electrons like to be as far away as possible from each other if it is not in between atoms. So right now, let's go back and check. Let's see if the oxygens still have full octet, and let's see if the central carbon still have octet. This oxygen here has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons, so this is good. This one here has 1, 2, 3, 4, 5, 6, 7, 8. So this one is also good. This carbon, central carbon, has 1, 2, 3, 4, 5, 6, 7, 8. So this carbon is also good. So this would be a good Lewis dot diagram. What it means is that right now you have, instead of one bond, you have two bonds. So I'm going to redraw this. You have two pairs, so I have two straight lines between this carbon and this here. Two pair, two single lines. So it has a double bond between this carbon and this oxygen, this carbon, this oxygen. And each of those oxygen will still have two, what they call lone pairs of electrons. Okay, so hopefully this helps. Try to do these ones after you watching this video. Okay, and I hope this video helps. Let me know if you have any other questions. Good luck. Bye now.